Namaste, welcome back to Siddhapragna channel and you are watching Machine Learning Basics Theory playlist. I hope you are enjoying these random topics in the machine learning. And as I already mentioned in the first video, these are not random topics actually. These are actually topics from the machine learning specialty exam itself. So when you are watching these topics or learning these topics, indirectly you are also preparing for the MLS certification. So bear that in mind and I hope you are enjoying. So in today's video, we are going to learn what are non-linear kernels in SVM. Okay, first of all, what is this? What is a non-linear kernel in SVM? So again, we are learning about non-linear kernels in SVM, which are support vector machines. Okay. This is a mathematical function which is used to transform the input data into a higher dimensional space where it becomes easier to separate the data points into distinct classes. We have seen something like this in one of the example where we have lowered the dimension to understand the features very easily. SVMs aim to find the optimal hyperplane that best separates the classes, and a non-linear kernel allows the SVM to create complex non-linear decision boundaries. Why use a non-linear kernel though? In many real-world data sets, the classes are not linearly separable. That is, you cannot draw a straight line to separate the classes effectively. A non-linear kernel enables the SVM to create a curved decision boundary that can better separate the classes in such cases. So if you are interested to see how nonlinear kernels work in SMM, this is how it does it. When you use a nonlinear kernel, the SVM algorithm implicitly maps the input features into a high dimensional space without having to compute this mapping explicitly. How does it do it? Using something called kernel trick. In the new space, it becomes easier for the SVM to find a hyperplane that separates the different classes, even if they were not separable in the original input space. And how does it do it? Using the nonlinear kernel. So basically, these are used in SVM, and the result is a more flexible model that can handle complex patterns in the data, which is particularly useful in cases like the one we are going to discuss in a minute. And that is concentric circles. Imagine a data set where the points form concentric circles. One circle representing class A and the other representing class B. In this original 2D space, no straight line can separate the points of these two classes. However, by using a nonlinear kernel, there are different types, but in particularly using RBF, which is radial basis function, the SVM can project the data into a higher dimensional space where the circles become linearly separable, allowing the SVM to find a decision boundary that separates the two classes. And now let's look at the common types of nonlinear kernels. So we have RBF, radial basis function, polynomial kernel, sigmoid. We might have heard about sigmoid in one of the algorithm, and then you have linear kernel. This is just for the comparison here. So let's go and learn about when would you use which kernel. So radial basis function, you would use it in image classification like handwriting recognition. Remember when we learned neural networks, we did the step-by-step explanation using handwritten digits images. Suppose you are building a system to recognize handwritten digits. The variations in handwriting styles mean that the digits are not linearly separated, right? An RBF kernel is well suited for this task because it can handle the complex variations in the data by mapping it to a higher dimensional space where the different digits become more easily separable. The RBF kernel's ability to model complex nonlinear relationships makes it ideal for higher dimensional data sets like images, where the decision boundary between different classes in this example between digits is not a simple straight line. And then we have polynomial kernel. You will use it in text classification, example, sentiment analysis. Imagine you are developing a sentiment analysis model to classify movie reviews as positive or negative. Sometimes the relationship between words and sentiment is more complex. For example, when specific combinations of words convey different sentiments. For example, not bad versus bad. The polynomial kernel can capture interactions between features, for example, word pairs or triples, and model these nonlinear relationships effectively, especially when you believe the relationship between the features and the outcome might involve interactions that are polynomial in nature. And then we have the sigmoid recommendation systems, example movie recommendations. Suppose you are working on a movie recommendation system where user preferences are highly individualized and complex. The sigmoid kernel, which resembles the neural network activation functions, that's where we have heard about sigmoid, can model the complex non-linear interactions between users and movies. The sigmoid kernel is similar to the activation function used in artificial neural networks, making it suitable for problems where the relationship between inputs and output resembles a multi-layer neural network. It can be used when you want to mimic the behavior of a neural network in an SVM context, especially when the data has a structure that suggests such interactions. And finally, we have linear kernel, just for the comparison purposes here. In a spam detection system, emails are classified as spam or not spam based on features like the frequency of certain words, presence of certain links, or other metadata. If the separation between spam and not spam emails can be achieved with a simple weighted sum of these features, then a linear kernel would be sufficient. But if the data is linearly separable or close to it, using a linear kernel is computationally efficient and easier to interpret. Linear SVMs are often used in text classification tasks where higher dimensional data like word counts in emails is typically linearly separable. So those are different types. I just want to put it there. We are not going to have step-by-step explanation for this one. And in summary, RBF kernel best for complex high dimensional data where classes are not linearly separable, such as image classification and certain bioinformatics tasks. And polynomial kernel, which is useful when you expect interactions between features to influence the outcome, such as in text classification tasks where feature interactions are important. And sigmoid kernel suitable for problems with data that might mimic neural network behavior, such as recommendation systems with complex non-linear relationships. And linear kernel is best when the data is linearly separable or when you have high dimensional data with a simple decision boundary, such as in some text classification tasks. Remember, each kernel has its strengths and is selected based on the characteristics of the dataset and the nature of the decision boundary between the classes. I hope you learned at least some basics of nonlinear kernels and etc. If so, don't forget to subscribe, like, and comment. See you in the next video. Have a great day. Peace out. Love you all.